So here's the next example. So just by looking at this, I can see that this thing is going to be shifted to the right 1. It's going to be reflected because of this negative, and it's going to move down 4 units. So I'm going to find my table by putting it in the graphing calculator. So I'm going to go to y equals and type in -2 to the x subtract 1, and then I've got an arrow over so I can go down and put -4. So let's look at the graph. What did I do? It's not an x. Okay, let's see if that does something better. Okay, this happened like we thought it would. It shifted down 4 units, 1 to the right, and instead of opening up like this, because of this negative sign, it actually goes down. But that doesn't mean it's a decay, because this number is bigger than 1. This is a growth. It's just a reflected growth. So I'm going to look at the table to make my points. I'm going to start down here with 1. I know I want to start with 1 because if I put 1 in for x, I get a 0 for the exponent. So at 1, I have the point -5. At 0, I have the point -4.5. At -1, I'm at 4.25. And notice that I'm just getting a smaller and smaller decimal to 4. So that must mean that I found my asymptote. So this thing is approaching this line right here, this horizontal line. So my asymptote is at y equals -4. And you're going to discover that whatever this number is going to help you determine your asymptote. That's the line that this graph approaches but never touches. So y equals -4. Notice that the domain is -infinity to infinity, and it's been that way on every single exponential graph. The range is the smallest to the biggest. The smallest y value is -infinity, and then it goes up to -4 and never touches it. The end behaviors, this end as x approaches -infinity, y is approaching -4. This end, as x approaches infinity, y approaches -infinity. Let's do one more. Y equals 1/3 to the x power. What do you notice is different about this one? I see this number that I'm taking to this power is a fraction. It's a number between 0 and 1. So this means that my graph is going to be a decay function. So when I type this into my calculator, it should look something like this. Now, notice I'm not adding or subtracting any number here. That means that I automatically know that my asymptote is going to be at y equals 0. Let's plug this in and see if we're right. I'll clear out what I have here. 2 parentheses, 1 divided by 3 parentheses, to the x power. So this one starts here and it decays because this is a number between 0 and 1. So it's going to look something like this. And you're welcome to use your graphing calculator to help you do the graph that you're going to do in Delta Math. Notice the asymptote is still at y equals 0. Let's think about our domain. Domain is -infinity to infinity. Range, the smallest y value is 0. The biggest y value is infinity. This end, as x approaches -infinity, y goes to infinity. And this end, as x approaches infinity, y goes to 0. Feel free, if you have issues with this lesson, email me. You may actually need to come in for some tutoring. I know that this unit's going to be tough, so don't be afraid to reach out and get help.